Hello, we're going to talk about the periodicity of a function. A real function f is said to be a periodic function in the domain if there exists a real number p strictly positive such that f of x plus p equals to f of x. A function can be admitting several numbers of period. Let's say P1, P2, P3 up to Pn. They are all periods of our given function, which verifies the above function. The one we call the period is the smallest and non-zero real number, which is denoted by t and is called the period of f on the domain of definition. Every multiple kt, where k is belonging to the set of natural number of period, verifies the equality. Here they want to mean this statement here. They want to mean that if you have a period and you take that period, you multiply it by another number, let's say k, any natural number k, that product you're going to get will also be a period of the given function. We usually know that the sine, the cos, the sec, the cosec, the period of these trigonometric identities is 2 pi. And we know that pi is the period of tan x and cot x. In general, if a function is defined as a sine bracket bx plus c and f of x is equal to a cos bracket bx plus c, where a, b and c are real number, then the period of these functions can be obtained as period t equals 2 pi over the absolute value of b. And when we have another two functions for tan and cotan, because we know that the period of tan is pi, then when a function is defined as this, tan of bx plus c and a cotan of bx plus c, its period will be obtained by taking pi, you divide by the absolute value of b, which means we have two alternative ways of calculating the period of a certain trigonometric function: by using the definition of the periodicity of a given function, or you can use these formulas to find the period of the function. If we have two functions, f and g, both of them they have a different period. Let's say the period of f is t1 and the period of g is t2. Because the two functions they are giving us a sum of f of x plus b of g of x. To get the period of the sum of two functions, we find the period of the first function, we find the period of the second function, then we find the lowest common multiple of those two given periods. That lowest common multiple is the one we call the period of the given function, which is the sum of two functions, the product of two functions, the quotient of two functions. It means that if you have the sum of two functions, the difference of two functions, the product of two functions, the quotient of two functions, you find the period of each function after you find what we call the lowest common multiple between the given periods. That lowest common multiple is the one we call the period of that given function. Examples: find the period of the following function. F of x is equal to 3x plus 5. Here we have two alternatives. One, we can use the definition. Another one, we can use the general case. Here for the definition, we know that the periodicity is when f of x plus p equals to f of x. We are going to find f of x plus p, which is equal to 3 cos of 3 x plus p, that replaces x, then plus 5. Then by the definition, when we take the f of x plus p, we equate it to f of x, we are getting this statement here. Then from here, we know that cos of an angle is equal to cos of an angle when they have the same angles. When we equate their angles, we add 2k pi on the right hand side to indicate that we can have the multiple of angles that belongs in the same quadrant with this angle here. That is to say, when you find the value of p, when you make p the subject of the formula, it will give us 3p equals to 2k pi. When you divide by 3, you will remain with p equals 2k pi over 3. But k is a set of positive real number 1, 2, 3, because they have told us that a function can have a multiple period. But the one we call a period is the one which is positive and smallest one. So it means the value of k, which is a positive value that can give us a smallest period, will be k. When you replace k here, it will give us the period as 2 pi over 3. Otherwise, this function can have a multiple of different periods, but the one we call the period is the one which is non-zero positive value, but the smallest one among of the periods we have. Case number 2, when we use the general case, we know that for a cos of bx plus c, its period is given as this one. When you identify from the given function, you see that b is 3. So when you come and replace there, you are getting the period as 2 pi divided by the absolute value of 3. Then p becomes 2 pi over 3. When we take example number 2, 3 sine of 5x minus 7. By definition, we have first of all to get f of x plus p. Then we said that for the function to be a period, it should be satisfying this condition. When we equate, we are getting this statement, which means when you make our p the subject of the formula, the period will be this one. But it will be 2k pi over 5. K can be 1, k can be 2, can be 3, can be 4, can be 5. It can be any number, which means that when k is 1, we are getting 2 pi over 5. When k is 2, we are getting 4 pi over 5. When k is 3, we are getting 6 pi over 5. All of those values, they are the period of our function. But the period is a non-zero and the smallest positive. Because the function can have many periods, that's why we take the smallest value of k as 1, that gives us the period of our given function as 2 pi over 5. For the general case, we can also find the period by using this concept, where our period of the sine of a function a sin bx plus c is given as p 2 pi over b, where b is the coefficient of x in our trigonometric function. When you observe, our b here is this, which is 5. So when you go and replace it in the formula of finding the period, then this b will be replaced by 5. It ends giving us this one as the period. When you observe, this one is the same as the answer we have obtained from the first case. The concept is valid also for tan, for cot, for sec. When we take an example here for tan 5x, when you find f of x plus p, we are getting tan of 5 bracket x plus p, because this x plus p should replace x here, and it gives us 5x plus 5p. So for the definition of the function to be the periodic function, it should be satisfying this condition, f of x plus p is equal to f of x. So when you equate them here, now we are going to add k pi. Why? Because we remember that the period of tan and cotan is k pi. So when you make p the subject of the formula, we are getting this statement here. So, but k is any value, any positive value, 1, 2, 3, because we know that we can have different periods. So we are going to take the smallest and the positive value, which is 1, and it ends up giving this one as the period of our tan 5x. When we use the general case, we have said that if our f of x is equal to a tan of bx plus c, where a, b, and c are real numbers, the period is given as pi over the absolute value of b, but b is the coefficient of x. So when you use this, when we take the above example, b is this 5, so it gives this one as the period of our tan of 5x. For this, find the period of sine squared x. So what we do for this sine x squared, we have first of all to express it in the standard form, where we have a, b, and c. So when we write sine squared x, it will be the same as 1 plus cos 2x over 2, and when you divide by 2, we are getting this one. As I have told you that when we have a function as the sum of two functions, we find the period of one function, we take the period of the second function. But this one is a constant number, this one has no period. So what we do, we find the period of cos 2x over 2, which will be equal to pi. According to the concept that we have talked above, try the following questions by finding their period.